The electron configuration of atoms are important factors in the physical or chemical properties of elements. So including the atomic size, ionization energy, as well as the metallic character. So based on the location of the different atoms, we can predict their physical and chemical properties, and this is determined by their number of electrons as well as their electron configuration. So atomic size is the average size of an atom measured experimentally. So usually it's categorized by the radius of an atom. So as you move across the same period to the right, the atomic size decreases. So this is because going left to right, the atoms has more protons, and more protons will basically result in a great pull on the electrons from the nucleus and to make the atoms smaller. So going left to right across the same period, and then the atomic sizes decrease. So as we move down from top to bottom, atomic size increases. That's because you have more and more atomic orbitals since you have a higher principal quantum number and the electrons start to occupy the outermost orbitals are further away from the nucleus. So that those make the atoms are bigger. So if we look at a practice question between lithium and potassium, so lithium and potassium, they're in the same group. Potassium is below lithium, has a more atomic orbital, so potassium is bigger. And between potassium and bromine, which is in the same period. So since bromine has more protons, then the protons can attract the electrons closer to the nucleus, make bromine smaller, so potassium is bigger. Between phosphorus and chlorine, so they're in the same period, and chlorine has higher number of protons, so make it smaller, so phosphorus has a larger atomic radius. So when predicting the atomic size, look at the periodic trends and follow the same type of prediction. So ionization energy is energy needed to remove an electron from the atom in the gaseous state. So basically, if the traction of the nucleus from the electrons is very large, that results in the high ionization energy. If the traction of a nucleus from the electrons is small, then it results in low ionization energy. So now the ionization energy decreases going down the same group. So this is because you're going down group, the atomic radius increases, so the traction from nucleus to electron decreases, the ionization energy decreases. So going from left to right, the atomic radius decreases across the same period, and then the traction is stronger, so the ionization increases going across the same period. So in generally, non-metal have higher ionization energy, metals have low ionization energy, while noble gas have the highest ionization energy since they are already very stable. So lastly, we'll look at metallic characters. So metallic characters are talking about, basically the character like metals. So metals tend to lose electrons in a chemical reaction from cations. So the easier atom lose electrons, then the more metallic their character. So in general, metallic characters is the opposite of the trend for ionization energy. So metallic character decreases as you move left to right across the same period, since we're going from metal to non-metal, and then metallic character increases going from top to bottom across the same group.